Hi everybody, this is Karen Smith coming to you with some mathematics review for your statistics course. So what I'm going to do in this video is I'm going to review some of the basic math and algebra skills that you'll need to know. Some of it might even be new, but if it is new, it's probably fairly simple. So this is stuff you need to know how to do in order to survive the formulas that we include in stats, okay? So it's pretty basic concepts though. If you're still struggling, even after you try a couple of examples, let me know, okay? I can give you guys more practice with this. I just want to make sure that you guys understand how to read a lot of the symbols you're going to encounter. With that, let's get started on our first topic, order of operations, okay? So, of course, in any math class, we have an order that we do things, right? The order that we apply the mathematics that we are given in each example. And the order of operations would be the order that we apply each operation on these numbers. So let's kind of review that and look at a couple examples. So you guys probably remember this. Please excuse my dear Aunt Sally. Okay, that's one way to remember the acronym for the order of operations. Better. Let's kind of remember what it is. This would be, parentheses would be what we handle first as far as what symbols we want to focus on when we're simplifying an expression. So parentheses, you could have brackets. And look, I'm going to kind of put a blanket over this whole thing. Let's just say, or other grouping symbols. Okay, so anything that groups numbers and symbols together, you want to look inside of the certain groupings, okay, and see if you can simplify. And I'll show you an example, okay. Right now, I want you to see how a fraction bar, fractions, okay, if you look at this, so you'll have 5 plus 2. Now let's put that up here in the numerator, over 14. Okay, in this case, you don't see parentheses, right? But you can imagine that there's a pair up in the numerator, okay? In this regard, the numerator, right, the fraction bar is acting like a grouping symbol. Okay, so keep that in mind, that you can have other symbols that are grouping symbols. Remember, there's absolute value as well, etc., etc. Okay, at any rate, this would be 7/14, and when we reduce 7 into itself once, into 14 twice, so 1/2 or 0.5. Okay, all right, so let's kind of go on from that. So once you handle your parentheses, next we do exponents. Now, a note that I want to give you guys about exponents, and this is such a simple concept, but not often actively thought about. Exponents apply to whatever symbol they are attached to. So let's just call it an object. To the object they're attached to. And to illustrate this to you, I'm going to give you this example, okay? And I'm just going to tell you, simplify this. Okay, let's have -2. Okay, and I'm going to raise that to the 4th power with parentheses. So -2 in parentheses. We'll call this example A. -2 in parentheses raised to the 4th power. Example B will be right under it, and we'll just put no parentheses, the negative sign, the 2, and then the 4th power. Okay? So, knowing what we know now, exponents apply to the objects they are attached to. And they can only be attached to one thing at a time, right? Unless you have grouping symbols. Right. So in example A, the 4 is attached to what? To the set of parentheses. So anything in the parentheses would come along for the ride as far as the exponent is concerned. So we're actually raising the set of whatever's in the parentheses fourth power, right? In other words, so we'll have -2 parentheses, -2 parentheses. And you must use the parentheses because that is what's raised to the fourth power. Remember, by the way, going back even further, exponents tell you how many times to multiply something times itself. So the fourth power says multiply this times itself 4 times. Ergo, we have 1, 2, 3, 4 -2s, okay, multiplied. Of course, now we have an even number of negatives, okay, so kind of check this out. Negative times a negative makes a positive, right? A negative times a negative makes a positive. So this will be positive 16. Okay, I just wanted to make that point for you. Okay, now let's take a look at B. At first, if we hadn't have said everything we said before, at first glance, maybe some of you would have said, oh, this is going to be positive 16 because it's, right, -2 to the fourth, an even number of times, right? A negative number times itself, even number of times. It's going to give you a positive value. But let's look a little closer and see what happens, knowing that the exponent is only going to apply to what it's attached to. Now, this exponent of 4 is only attached to what? The 2. Okay? So that is what gets written. Only that object gets written 4 times in multiplication. So 2 times 2 times 2. And then everything else comes along for the ride. So that negative sign, and I'll put it in blue, this guy is blue because he's all sad and alone, right? That just goes along for the ride out in front. Okay, and so now we can go ahead and multiply our 2's, right? 2 times 2 times 2 times 2 is 16. And the negative comes along for the ride. So -16. Note the difference in my outcomes here. Do not confuse these two things, okay? Remember, you can't go wrong. You don't have to memorize anything here as long as you understand that the exponent will apply only to the object. And I'm not saying the number and I'm not saying the symbol. Whatever the exponent is hooked up to, that's what repeats itself. Another note with exponents, we're going to include square roots now because the square root of A can be written with a fraction exponent. Okay, so for example, if I write something to this effect, if I write 4 to the 1/2 power and simplify it, please, you can simplify this as the square root of 4, which is just 2. Okay, so that's easy to remember, easy enough anyway. So there we go. Let's move right along. Okay, now we will multiply, and I should say, and or divide from left to right. Okay, and so you're looking for multiplication and or division. Don't forget, multiplication can be written with a dot between two things. For example, if I have A dot B, that's multiplying. This would be the same thing as if I wrote A and then parenthesis B. Okay, of course, all this you used to know as A with a times B. And finally, we will add and or subtract, okay? So now we're going to do the same thing we just did with multiplication and division, except we'll add and or subtract left to right. And there you have your order of operations. Let's take a look at A. And just to kind of remind you, I'll put the PEMDAS up here. Okay, parentheses, exponents, multiply, divide. Okay, add, subtract. So now let's look at A. So parentheses would mean that we want to work inside the set of parentheses first. We'll bring down anything we're not working with yet. We're not going to use the 16. We're going to bring that minus 3 inside the parentheses there. 5. Bring that square. So don't forget any or haven't applied yet. You want to bring it down every time. Don't just bring down the part you're working on or whatever. Bring everything down. Okay. So we did that part. So now the next thing is the exponent. Okay. Now remember, our exponent of 2 is attached directly to the parentheses there. So anything in the parentheses is going to be squared. Of course, it's a 5. Just want to remind you of that. So we have 16 minus 3 times 20 divided by 5. Once you apply the square, once you apply that exponent, it's gone, right? We don't have to worry about it anymore. I mean, you can get rid of it. So the next step is negative 3 times 25. Bring down things you haven't worked on yet. So we'll have what, negative 75, and then divided by 5. So if I have to choose between the subtraction and the division, I'm going to choose division. Okay, so 16 minus, and 75 divided by 5 is what? It's 15, right? And then, of course, finally, 16 minus 15 is 1. So here is our answer for A. In B, I chose because I had mentioned that a fraction bar can kind of serve as its own little type of grouping symbol. And so in this regard, it is, because we have to simplify inside the numerator and inside the denominator first. So let's do that. So we'll bring down the 6 plus. Okay, now my numerator is 16 minus 4. So what? 16 minus 4 is 12. Now, in this denominator, I have to apply the square to the 2 first, right? So that has to go first. So we'll have what? 4 plus 2, or what? A 6 in my denominator. Okay? So let's go bring down that, subtract to 2. So now, before we go outward, we need to go ahead and simplify the fraction 12 over 6. So that's 2. 6 plus 2 minus 2. And now you can go from left to right with addition and subtraction. So we'll have this first, right? 6 plus 2 is 8 minus 2. And of course, it ends up at 6. And this is the answer for B. Okay, so quick note. The variable n will represent the number of items in a data set. Okay, so for example, in the next example, when we go below here, A is 0, 1, 3, and 5. Okay, so we'll say A is the set 0, 1, 3, and 5. Well, for this data set, there are 1, 2, 3, 4 elements. So n is 4. Simply, we needed a variable that represented the number of items in a data set. And that's what the letter N will do for the rest of this semester, for the rest of statistics in your life. Okay, let E be the set of even integers between 1 and 7. Let's think about it. We have 1, 2, 3, 4, 5, 6, 7. So if you need to visualize, go for it. Even numbers are here. So that would be the set E. Capital letters, are going to generally represent sets, data sets, okay, or collections, or something called a random variable, which is a list of values. So we'll get to that soon enough. So we have 2, 4, and 6 here. So now what is n? N is, in this case, 3. So for this one, n is equal to 3. Okay. Next, I want to talk about summation notation, or sigma notation. And what this has to do with is adding up a list of values. So when you see sigma, the uppercase Greek letter sigma, when you see it in front of a variable or something to that effect, for example, if I have sigma x, and this is just telling me that I have a list of x values. Maybe x is 0, 1, 2, 3, 4, 5, and 6. What this is telling me is add up all of the values, the x values that I have here. Okay, but let's look at our examples that we have here. Okay, in part A, I have an indexed sum. So what this is telling me is to note the location of each datum in the data set. By the way, datum, D-A-T-U-M, is singular, right? It's just one singular. And then data would actually be plural. We have a list of data, and in the position of A2, the second position is the datum 1. Okay, so there's the usage of datum and data. Anyway, for A, now in blue here, you'll notice I wrote location and data set, and I wrote A sub 1, A sub 2, A subscript, right? A3, A4. And so that's just to kind of show us the location in the data set. Okay, and so my indexed sum is telling me which of the data set, or what part of the data set I need to add up. And so I need to add up items 1 through 3. So that means I need to add up A1, A2, and A3. So that's all that should be included in this sum here, in the first sum. And so that's what we're going to do. We're going to add those up. And so we'll have, so that would be 4. Okay, in part B. In part B, there is no indexing. So when there's no indexing, it's just sigma A, right? It means add up all the values. So we add up everything in the list. It's quite simple. So if you tried that, you should get 9. Okay? Now, on parts C and D, we have a little more work to it. And this is where we do want to kind of remember the order of operations on it. So let's take a look. We have an x squared in our summation here, and we have parentheses. So summation is applying to whatever's right after it. Okay, and when there are parentheses, anything in the parentheses, like in part C, all that is included in my summation. But let me show you how this most simple way to handle it. Okay, what I want to do here on the right side is I'm going to just make a little table with my data set. And for part C, we want to just kind of take the inside of the parentheses bit by bit. So first what I'm going to do is kind of highlight for what values in this statement are included in the summation. So we have to take each x value, or take each a value, square it and subtract 1. Then we'll add those values up. In D, notice if there are no parentheses, whatever is right behind or right after the summation would be included in the summation. Okay, so we would get that sum and finally subtract 1 from whatever sum we would get. And we'll get to that. Let's look at C first. So what I'm going to do for part C is I'm going to begin by squaring up each value in my data set. Okay, so 0 squared, and I'm in the second column of this table. We have 0 squared, 1 squared, 3 squared is 9, 5 squared is 25. And now I'm going to take each squared value, right? This is the column I just made, right? So let me make a little 1 here. And then the second column that I'm going to create here is going to be all of it. Okay, so we'll do all of the whole set of parentheses. Okay, for column 2 or column 3, this next one. So let's subtract 1 from each one. So 0 minus 1, right? 0 minus 1, negative 1. 1 minus 1 is 0. 9 minus 1, 8. 25 minus 1, 24. And so what you're going to do here is you're going to add up the squares minus 1, and that's the answer. So we'll have this for our summation. -1 plus 0 plus 8 plus 24. And finally, you would have 31 for that one. Now for D, it's a little simpler, I think. It's shorter. First, we'll find the square. And by the way, you're going to hear, and you may have already, if you started reading or flipping through things about statistics, you may have already heard a lot about the sum of squares. This is called the sum, right? Summation of the squares, okay? So you're going to hear more and more about that, but that's simply what that means, is the sum of squares. So don't get intimidated by the language barrier. That's what I'm here to help you with. So at any rate, let's go ahead and add up the squares. So we will have, and I'm going to go ahead and use parentheses to denote what happens first. So for this for part D here, we're actually going to just utilize this column here. So we're adding up the squared column. Okay? So just take those values and add them up. 0 plus 1 plus 9 plus 25. And then after we add those up, we'll subtract that 1. Okay? That's that. So let's do that. If you do this correctly, here's what you get. The answer, 35. Okay, so if you did it correctly, 35 is part D. Okay, we'll get used to this. Now, this is done by hand in these examples. You guys are going to be allowed to use calculators. I have a website. When you get into our course page, more into the sections where we need this, I'll show you guys how to use the TI 8384, Texas Instruments, and even Excel is very useful when it comes to this type of operation. It'll save you a lot of time. So yeah, make sure you get recommendations for calculators. I like the TI 30X2S. That's a good one. It's a small one. It's a very inexpensive calculator. I'll write it down for you guys. Let's see. TI Texas Instruments 30X2S. Okay, that's a small one. I like the TI 83, 84, okay, as well. Alrighty, so here, that's my recommendations for calculators if you're going to go out and get a good graphing calculator. Definitely options for you, and you'll get help with these too. And finally, in this review, we have factorials. So when you see an exclamation point written at the end of, it's right after a number, for example, 3 factorial, okay, so when you see that 3 factorial is equal to whatever, then what you want to do is multiply, starting with this number, this integer, counting backwards. Increments of 1. Just count backwards. And that's it. You stop at 1, okay? So it's really just natural numbers or positive integers that this works for. So then you get a 6 for this. Now, here's a little list. To help you to get used to it, you may want to make a little table of factorials. If you make your own chart or table, always begin with the fact that 0 factorial is equal to 1. Okay, and that's kind of like right here. 0 factorial, just by the way they defined it. Okay, so here's some example. Okay, let's say the directions would be simplify. And let's say we have 4 factorial divided by 3 factorial. Okay, in this A. Now, you won't always have to write it out, but I'm just going to show you how we divide factorials. It's quite simple. Okay, and so you'll have, remember, 4 factorial is 4, 3, 2, 1, right, as a multiplication. And then 3 factorial would be 3, 2 times 1, okay, multiplied. Now you can see that 3 factorial is contained inside of 4 factorial. So if you have the smaller factorial, you see that 3 is the smaller factorial. So this guy, the whole thing cancels, right? And so you canceled that on the 4. But remember that you still have something left to simplify, right? Okay, so you still have the 4. Naturally, that's going to be the answer in this case. So let's give our answer. Okay, and so we'll have equal to 4. All right, so what if it wasn't 4? Let's see, what would we do? So let's have that. Okay, example B. So we have 10 factorial divided by 7 factorial. Okay, so let's have a closer look. Now, look, 7 factorial is just 7 times 6 times 5 times 4. You don't have to write it all out. But what you can recognize, similar to the previous example, is that 7 factorial is contained inside of 10. And here's what we're going to do. Instead of writing everything out 7 and below, we're just going to write 10 times 9 times 8. Stop there. I'm going to write times 7 factorial, right? Because it goes times 6 times 5, excuse me, etc., etc., until 1. So if you recognize and kind of can envision the 7 factorial being inside of the 10 factorial, you're in business, because here's what happens, right? It just, it's going to cancel. Okay, and so that's kind of nice thing that's going to happen. You can kind of just multiply the 10, 9, and the 8. So you'll have, 90 times 8? Or 720. Okay, so that is that, you guys. These are factorials, summation or sigma notation, order of operations. I will have a separate tutorial for linear equations, so if you want to start looking up things like slope-intercept form, we'll get to that when we get to that, okay? But this is what you need to know now, okay, for the first chapter. So not that bad, huh? Let's get moving.